My name is Nan Abe, and today I would like to talk about Typespark, column-wise type annotations for PySpark DataFrames. Let's jump straight in. I love PySpark. However, in production code, I don't like seeing this. A function that takes as an input a data frame and returns another data frame. Because how do I know which columns are supposed to be in those data frames? Sure, I could evaluate the code to find out. But figuring this out from the code could be difficult if there's hundreds of thousands of lines of code written over the years by people that don't even work at the company anymore. So to solve this, we've developed Typespark, where we define a schema, in this case person, with these three columns and these three data types, and we annotate the input and the output to this function using that schema. Today I'll show you that this leads to improved readability of the code, type checking both during runtime and linting, autocomplete of column names, easy refactoring of column names, and easier unit testing. Cool, let's see that in action. Here we have a function called getDocs, which takes as an input a pets data frame and returns another data frame. Internally, it filters the pets data frame on the column species, which should be equal to doc. Let's convert this to Typespark. We'll define this as a data set of the schema pets that I've defined before. Here you can see it, so it has these columns and these data types. And the return type will also be a data set of type pets. And then this call species I can replace by pets species. Also note the autocomplete here, which is very useful. I always forget which columns are present in a given data frame. What's nice about this is that if I want to rename this species column, I can simply right click it, rename symbol, and rename species into type, for example. And now this renaming will propagate through the code base. So you will also see this change here, for example. Another nice thing is that if I indicate that, for example, I want the return type here to be owners, the linter immediately tells me that that is not actually what I'm returning. Expression of type dataset pets cannot be assigned to the return type dataset owners. So this allows us to catch errors really early on, which greatly improves the speed of development. All right, let's fix that again. Typespark also allows you to write unit tests easier. So here I've written a unit test. We have a test getDocs. We use a Typespark function called create partially filled dataset, which takes the schema as an input, as well as a definition of some of the data in the schema or in the dataset. So here we have defined the column pet ID to be 1, 2, 3, and type to be dog, cat, dog. All the other columns get initialized with null values. I store this in pets. I run pets through the getDocs function, which I store in observed. And then I also define an expected, which also use create partially filled dataset, where I've now defined 1, 3 and dog, dog, because I expect that the cat will be filtered out. Then I use chispas assert df equality to check whether observed and expected are the same. And let's run that. And this will also allow us to catch errors early on. We make these unit tests, and if anything is wrong, we'll find out within, well, in this case, a few seconds. Check out a more complicated example. We'll do find owners who need to renew their pets vaccinations. So this takes as an input 3 data frames: owners, pets, and vaccinations. And it returns another data frame. It essentially joins these 3 data frames on top of each other: owners, pets, and then vaccinations, all joined. It filters on the next due date, which should be lesser than or equal than today. And then there's a with column full name, which is a concatenation of first name and last name. And then there's some with columns that are just basically renames. Cool, let's convert this into Typespark as well. So this one is a data set of schema owners. This one is a data set of schema pets. You've seen that one before. This one is a data set of schema vaccinations, and all these schemas I've defined beforehand, just like I did for pets. This one is a data set of what I call a reminder. Now, as soon as I define the return type, you see that I get a linting error. Essentially, expression of type DataFrame cannot be assigned to return type dataset reminder. It this is a data frame that comes out of here. So it doesn't really understand that this leads to a new set of columns, and that should correspond to reminder. So I need to help the linter a little bit here, and I do that with a casting operation. So this makes the linter happy. What it will also do is during runtime, it will actually check that what is returned here follows the schema reminder. So as long as I run this function frequently, for example through a unit test or through scheduled pipelines, I can be sure that the return type of this function is indeed a dataset reminder. To do this, I actually also need to select a couple of columns, because I know that right now this has many more columns that we don't actually want. So I'll do a select statement for now, which says reminder.all column names, to just subset it to the columns in reminder. All right, we can also change a couple of these column functions. So first name comes from owner, last name also comes from owner, email also comes from owner, and I like specifically explicitly specifying these, because it makes it very clear where each column comes from. Otherwise you have to do a lot of guesswork. Here I actually made a mistake, which is interesting. I said that vaccine name should come from owners. It doesn't, and that's why it shows up as white. This should have been vaccinations. Once again, this allows you to catch errors early on. This one is also vaccinations. Next due date, yes. The next due date is also up here. Let's change it here as well. You can also change this on the left hand side. So this is reminder full name. You can see that the linter doesn't like this, because with column actually expects a string and not a column object. So we have to add .str here to indicate that we want a string representation. All right, two more. .str. Cool. So what we have now is a join and a filter, some operations here on a data frame, followed by a couple of with column transformations, followed by a select to the column of the schema, followed by a cast. This is a pattern that we actually see a lot, and that's why we've abstracted that away. So what we can do to make this a little bit shorter is transform to schema. We'll do this whole block up to here. We'll give it the reminder schema, and then we'll define the transformations that we want, which is indeed this part. And then we can remove all of these with columns and the select, because that will now be taken care of within the transform to schema, which is really nice. This really tidies up the code quite a bit. So we can do one more thing, which is we still have columns defined as strings over here in these joins. And we're just going to do the same thing here. So let's see, owners .owner ID, we want that to match pets.owner ID indeed. And pets.pet ID should be vaccinations.pet ID. That's great. Now this will actually result in a error because of ambiguous column names. Can't go into it right now, it takes a little bit too much time, but Spark basically can't figure out that this column belongs to this data frame and this column belongs to this data frame. So we need to help Spark a little bit here. The way we'll do that is as follows. Owners is register schema to dataset, and we'll do that as such. Essentially, we're specifically telling Typespark that this owner's schema now specifically belongs to this owner's data frame or data set. We're going to do the same thing for the other schema, so pets, and then also vaccinations. And we'll put the right ones in the right places. All right, and that's it. And what's really cool about this is that we also don't assume anymore necessarily that, for example, owner ID will stay the same So if we just want to rename pet's owner ID into owner's ID, then we can, and this code will still work. This will propagate throughout the code for all pets schemas, but we don't implicitly assume anymore that between owners and pets, this column name remains the same, which we actually did before. All right, there is more actually. We can use Typespark also in notebooks. So here I've prepared a little notebook. We start a Spark session. We use a little helper function called catalogs, or helper class catalogs, which comes from Typespark, which shows us all of the tables that are present in a certain catalog. So for the database object that we defined here, we have the Spark catalog, and then we have several databases in here. Let's take the veterinary one, and I would like to take the vaccinations one. And we can then load our data as such. When we run this, it returns two things: vaccinations with a lowercase v and uppercase vaccinations. Lowercase vaccinations is simply your data frame that you're used to, so it looks like this. Uppercase vaccinations is the schema. And what's interesting here is that I didn't actually save this particular table using Typespark. So you can run this on any table that you have in your database, and it will produce the schema for you. So if you're migrating your current data into Typespark, you can actually load it as such, generate the schema, copy paste that into your IDE and use it there. You can also use it within your notebooks, because if we now want to, for example, filter the vaccinations on something, so let's see the vaccine name, for example, we can get autocomplete on this, which is really nice. All right. So I've showed you that Typespark leads to improved readability of code, type checking both during runtime and linting, autocomplete of column names, easy refactoring of column names, easier unit testing, and more. I've shown you some of the functionality in notebooks, but I promise you there is even more. If you want to know more about us, check us out on GitHub, read the docs, or simply scan this QR code to go to our GitHub page. Thank you very much.